Astronomers detect faint flickers from across the universe almost daily. To catch these gamma-ray bursts, the death cries of massive stars, humanity maintains a dedicated fleet of sensitive telescopes in continuous orbit around the Earth. On October 9, 2022, that routine monitoring was replaced by a torrent of light. It slammed into the orbital network with such violence that most of the detectors simply saturated, leaving our most sensitive instruments blinded by the glare. The impact reached past our satellites. The burst carried so much energy that when its light arrived, it physically compressed the ionosphere, the electrically charged shell of air sitting tens of kilometers above your head. Researchers tracking the event recorded a sudden, sharp drop in the altitude of that layer. They measured this atmospheric disruption through its effect on radio signals bouncing around the planet, a signature comparable to a major solar flare. This disturbance did not come from our sun, 8 light minutes away. It was a dead star, 2 billion light-years in the past. An event at a distance nearly meaningless to the human mind had the raw physical reach to stir the air directly above our heads. Astronomers cataloged the burst as GRB 221009A, but its behavior was anything but standard. The data showed an explosion 50 to 70 times brighter than any previously recorded. The nickname, BOAT, the brightest of all time, stuck because nothing else fit. Because the blast broke the very instruments built to measure it, researchers had to reconstruct the peak of the explosion from its edges. Like estimating the height of a wave from the water it leaves on the shore, they had to piece together physics the saturated detectors could not record directly. Hidden inside that data wreckage was a single narrow feature in the spectrum. While gamma-ray bursts usually produce a featureless roar of energy, this was a clear chemical fingerprint, a specific emission line that had eluded astronomers for 50 years. The event was so overwhelming, it forced us to look past the limits of our engineering. By stretching our methods to account for the instrument's failure, we finally uncovered the unprecedented signal hiding inside the noise. When scientists split the light into individual energies, they found a distinct emission line rising to a peak energy of about 12 million electron-volts, or 12 MeV. It lasted for 40 seconds before fading away. To interpret that value, we have to look at the rules of particle physics. When an electron, a particle of ordinary matter, meets its antimatter twin, the positron, they do not bounce, they annihilate, converting their entire mass into pure energy. That energy emerges as gamma rays at a very precise value. Matter and antimatter erasing one another leaves a signature of exactly 0.511 million electron-volts. The BOAT's data presented a massive gap. Down here is the expected signature of antimatter annihilation at 0.511 MeV, but the observed signal hit at 12 MeV, nearly 24 times higher on the energy scale. Reconciling that gentle, known signature of antimatter with the 12 MeV spike recorded in the data requires accounting for a specific kind of cosmic violence. As the star collapsed, its rapid spin fired a relativistic jet of material at 99.9% the speed of light. That beam was aimed almost exactly at us. Racing toward us near light speed, the jet's light was crushed to higher energies. Accounting for this motion, the 12 MeV line slides perfectly down to the energy of electron-positron annihilation. The jet became a factory, churning out matter-antimatter pairs that immediately annihilated. This capture of the universe's rulebook in motion showed raw energy converting into physical matter and back again at the absolute limits of physics. After the initial glow, astronomers turned their attention to the supernova wreckage. Long-held models suggest that massive stellar explosions like this forge the universe's heaviest elements through a process called rapid neutron capture. To find proof, we turned the Webb telescope's infrared eye toward the fading BOAT, hunting for the chemical glow of newly minted gold and platinum. Despite being the most powerful stellar explosion ever witnessed, the telescope found nothing of the sort. No clear signature of rapid neutron capture appeared in the spectrum, and no trace of freshly forged heavy elements could be found. The explosion that broke our instruments and confirmed extreme antimatter physics failed to produce the basic cosmic treasures we were certain it would make. A single beam of light crossed 2 billion years of space, brushed against our atmosphere, and handed us the most energetic light particles ever measured. By failing to make heavy elements, the BOT leaves a haunting question about where the very building blocks of our reality, including the gold in the ring on your hand, actually come from. The Brightest of All Time reminded us that the universe remains fully capable of doing things we did not expect, subverting our best theories from 2 billion light-years away to touch the sky we stand under right now.